Hello, this online lecture is about bonds and energy, how bonds form, how their energy changes, and what you have to do energy-wise in order to break a bond. Before we get into the energy part of it, let's just talk a little bit about what happens when atoms approach each other. If you think about it, an atom basically has two regions. There's the electron cloud on the outside, and the electron cloud is negative. And then there's the nucleus on the inside, and the nucleus is positive. So when two atoms are really far apart, they kind of really don't even know that they exist. So if there was an atom like over here, it wouldn't really even be interacting with this atom because they're so very far apart. But when atoms get closer together, forces start to come into play, forces of attraction between charges. So let's say we had an atom right here. You start to get a force of attraction between this side of this atom's electron cloud and the other atom's nucleus. They would be attracted to each other because the electron cloud is negative and the nucleus is positive. At the same time, this atom's electron cloud and this atom's nucleus would be attracted to each other as well. So you're starting to get a force of attraction. Now, as the atoms approach each other, what happens is, if it's a covalent bond, you're going to have unshared paired of electrons, and they're going to kind of occupy this part of the electron cloud. And the electron clouds of the atoms will actually eventually start to kind of overlap a little bit, like this. And then what you'll have is the two unshared electrons, one from each atom, are kind of living in that space. And so these electrons get attracted to the other atom's nucleus. And that attraction is what results in what we call a covalent bond that really kind of holds the atom together. But at this distance, some other forces are starting to come into play as well. For instance, this nucleus is positive, and this nucleus is positive, and like charges repel each other. So because these two are starting to get close to each other, instead of drawing them closer, there's actually a force that's pushing them away. There's a force of repulsion because they're getting near each other. And likewise, the rest of this electron cloud and the rest of this electron cloud, they're both negative, and they're starting to get close to each other. So those electron clouds are starting to repel each other as well. When an atom is bonded, these forces are in balance. If the atoms move too close together, then the forces of repulsion will get a lot stronger. And if the atom starts to drift apart, then the forces of attraction become stronger and take over. And so it kind of holds it at that equilibrium point where it's most stable and bonded. So that's kind of what happens when two atoms approach each other, and these attractions and repulsions kind of come into play. Now, the attractions and repulsions translate into a type of energy, potential energy. So what I'm going to do is I'm going to draw a little graph here, and on the x-axis of my graph I'm going to put distance, so the distance between the two atoms, and on the y-axis of the graph I'm going to put potential energy. And that's the energy that exists between these two atoms, that's stored between these two atoms. I'm going to draw like a dashed line right here, and that's going to be zero potential energy. And basically that happens when the two atoms are at they're so far apart that they're really not even interacting with each other. They're just kind of chilling out and they're not really attracting or repelling each other, and at that point the potential energy would be zero. And it'll be zero, at any greater distance it would be zero as well. But then as the atoms start to come together, what happens is these attractive forces start to kick in. And so as the atoms come together and the attractive forces kick in, what happens is the potential energy will actually drop until it hits a point where it's going to be at its lowest. And that's that equilibrium point that I was talking about before, where the attractive forces and the repulsive forces are balanced with each other. At that point, the bond will be stable between the two atoms, and the potential energy will be at its lowest point. But if the atoms start to creep closer to each other, let's go ahead and just draw that. If the atoms start to creep closer to each other, you're getting way more overlap of the electron cloud, and the repulsive forces inside of the atoms are much stronger. So the electron clouds pushing away from each other, the nucleus is pushing away from each other, they become much stronger, and that causes the potential energy to go back up again. It actually goes up really, really quickly as they get closer and closer. So this point right here, where the potential energy is the lowest, that correlates to the atoms in a stable bond. So I'll go ahead and draw that up here. So the atoms the overlap is just right, and they're just the right distance apart from each other to have that stable bond. And the distance from this lowest point up to the 0 point of potential energy, right? That's the bond energy of that bond. So let's just say, for example, that it's negative 200. For this example, we'll just make up a number. It doesn't really matter. So negative 200 is fine. We're just going to say it's negative 200 kilojoules per mole, which is a unit that we use to measure potential energy in. So that is the potential energy of this bonded pair of atoms when their bond is most stable. And you can see when they're so far apart that they're not even interacting, the potential energy is 0 kilojoules per mole. And then as the atoms get too close, the potential energy starts to skyrocket, and we actually kind of get into positive potential energies really, really quickly because they're too close together. So the stable bonded atoms are going to have a negative potential energy, and that's the potential energy that you have when the bond is the most stable. Now let's say I wanted to break this bond. Let's say this was two hydrogen atoms and I wanted to split them apart. It's interesting because I want to basically get them from here on the graph to here on the graph. So what's the difference between this point on the graph and this point on the graph? The difference is potential energy. So if I want to get atoms from here to here, I have to add this much potential energy to the atoms. I have to add that much and get them back up here. So if the potential energy at the stable point, the lowest point, is negative 200 kilojoules per mole, and I want to break them apart, get them over here, then I would have to add 200 kilojoules per mole. See? So this bond energy, even though it's negative, that's the amount of energy you have to add to bonded atoms to get them to split apart. So that's how it works, and it works that way with any pair of bonded atoms. There's always going to be a bond energy where the two atoms are the most stable. It's going to be a negative energy, and that's the amount of energy you have to add to get them to split apart. And the reason why that energy is stable right there is because that's the optimum distance where the attractive forces and the repulsive forces are balanced out. So that concludes this little video lecture. As always, if you have questions, feel free to ask in class, and thank you for watching.